When we think about muscle growth, especially as we age, most people immediately picture protein shakes or the classic eat more eggs advice. But here's the truth: science tells us something very different. There is one overlooked, inexpensive food, something you can find in nearly every grocery store, that actually outperforms eggs for building and maintaining muscle even well into your 70s and 80s. Today, I'm going to break down exactly what that food is, why it works at the cellular level, and how you can start using it immediately to strengthen your body and extend not just your lifespan, but your health span. Muscle growth is often framed as a simple matter of eating more protein, lifting heavy weights, and allowing the body time to recover. While this is broadly true, the nuance lies in the type of protein and how efficiently the body can actually absorb and use it. Protein quality and bioavailability are two concepts that are often misunderstood, yet are absolutely fundamental when it comes to building muscle, especially as we age. To understand this properly, it's helpful to think about protein not as a single nutrient, but as a collection of building blocks known as amino acids. These amino acids are the raw materials your body uses to synthesize new muscle tissue, repair damaged fibers, and regulate countless other processes like enzyme production, neurotransmitter balance, and even immune function. Not all proteins are created equal, however, because the amino acid composition varies depending on the source of protein and the digestibility of that protein once it enters your system. When we eat protein, the digestive system breaks it down into amino acids, which then circulate in the bloodstream and are made available to tissues like skeletal muscle. For muscle protein synthesis, the process by which muscle tissue grows and repairs, the body especially relies on essential amino acids, the 9 amino acids that the body cannot make on its own. Of these, leucine is the most critical for stimulating what's known as the mTR pathway, the molecular switch that tells the body, in essence, it's time to build muscle. The concentration of leucine in a food, along with how bioavailable it is, has a massive impact on whether or not that protein source will be effective in driving muscle growth. Eggs are often thought of as the gold standard because they contain a complete set of essential amino acids and are relatively well absorbed. However, the metric we use to evaluate protein quality has advanced over time. Older systems like the Protein Digestibility Corrected Amino Acid Score, PDCASs, have been replaced by the Digestible Indispensable Amino Acid Score, ADISS, which gives a more precise picture of how the amino acids in a given protein source are actually utilized in the body. What researchers are now finding is that several affordable, overlooked foods rank higher than eggs when it comes to DIAS, meaning that gram for gram, the body can do more with that protein. Bioavailability is where many people make the mistake of equating sheer protein grams with muscle building power. For example, you could eat 30 grams of protein from a low quality, low bioavailability source and get less muscle synthesis compared to 20 grams from a high quality, high bioavailability source. The reason is that the first food might lack sufficient leucine or other key amino acids, or it may contain compounds that inhibit absorption in the gut. By contrast, the second food might provide a dense, balanced profile of essential amino acids in a form the body can rapidly digest and transport into muscle cells. This distinction becomes even more important as we age because older adults experience what's called anabolic resistance. Anabolic resistance is the reduced sensitivity of muscle tissue to the anabolic or growth-promoting effects of amino acids. In practical terms, it means that the same meal that stimulated robust muscle protein synthesis at age 25 will have a much weaker effect at age 70. To overcome this, older individuals need either more protein per meal or higher quality protein with superior bioavailability to reach the same anabolic threshold. This is where focusing on protein quality over quantity becomes essential. If someone is simply told to more protein without regard for the source, they may end up increasing calories without truly addressing the muscle maintenance problem. This is one reason why populations consuming diets high in low-quality protein sources often see muscle wasting and frailty at earlier ages, even if their total protein intake looks adequate on paper. Conversely, when individuals strategically choose protein sources rich in essential amino acids, especially leucine, they can counteract anabolic resistance and maintain strong, functional muscle tissue well into older age. The body's capacity to absorb protein is also influenced by factors like digestion rate and the presence of other nutrients. For example, whey protein, often derived from milk, is considered fast digesting, leading to a rapid spike in amino acids in the bloodstream and a strong, immediate stimulation of muscle protein synthesis. Casein, also from milk, digests more slowly, providing a prolonged release of amino acids over several hours. Eggs sit somewhere in the middle, but their digestibility can vary depending on whether they are cooked or raw. Interestingly, raw egg protein is only about half as bioavailable as cooked egg protein, which means even within a single food type, preparation makes a difference. Meanwhile, certain plant-based proteins like soy, lentils, and even specific grains or legumes, when prepared correctly, can deliver an amino acid profile that not only rivals, but sometimes surpasses that of eggs in terms of actual usable protein for muscle growth. It's also important to highlight that bioavailability is not just a matter of the amino acid profile, but also of anti-nutritional factors. Many plant proteins, for instance, contain compounds like phytates or tannins that can interfere with digestion and absorption. However, methods such as soaking, sprouting, and fermenting can significantly reduce these inhibitors, increasing the net bioavailability of the protein. What this means in practice is that traditional preparation methods, which may seem outdated, often hold the key to unlocking the full anabolic potential of inexpensive plant-based foods. Modern nutrition science is now catching up to what many cultures have known for centuries, that how you prepare food can be just as important as what food you eat. Another layer to this discussion is the concept of the leucine threshold. For muscle protein synthesis to be maximally triggered, the body needs a certain amount of leucine in a single meal. This threshold is typically around 2.5 to 3 grams for younger adults, but may rise closer to 4 grams or more in older adults due to anabolic resistance. An egg contains about half a gram of leucine, meaning you'd need several eggs to cross the threshold. On the other hand, some alternative protein sources provide higher leucine concentrations per serving, making it easier and cheaper to hit the necessary anabolic trigger point without excessive calorie intake. This is particularly important for older adults who may struggle with appetite or have difficulty consuming large amounts of food in one sitting. Finally, understanding protein quality and bioavailability forces us to rethink the way we give dietary advice. Instead of vague recommendations like eat more protein or make sure to include eggs, a more precise framework involves identifying which foods deliver the highest quality amino acids in the most bioavailable form and structuring meals around those foods. This precision is what separates average outcomes from optimal outcomes, especially when the goal is not just to add muscle mass, but to preserve functional strength, mobility, and independence across the lifespan. Protein quality measured through metrics like DIAS and validated by real-world outcomes in muscle protein synthesis is the foundation of that framework. For decades, the conversation around muscle growth has been dominated by animal-based protein sources, particularly eggs, milk, and meat. These foods have been considered superior because they contain all the essential amino acids and have relatively high digestibility. However, recent research has revealed a surprising truth. Certain inexpensive plant-based proteins not only hold their own, but in many cases outperform eggs in preserving muscle mass, particularly in older adults. This discovery challenges long-held assumptions and opens new opportunities for building and maintaining strength across the lifespan without relying solely on traditional animal sources. The common belief that plant proteins are inherently inferior is rooted in outdated measures of protein quality and in incomplete understandings of digestion and absorption. Historically, the protein digestibility corrected amino acid score, PDCAS, was used to rank proteins, and by this system, animal proteins often came out on top. But the newer and more accurate digestible indispensable amino acid score, DIS, paints a different picture. DIS accounts for not just the amino acid composition, but also the digestibility of each essential amino acid specifically in the small intestine. When evaluated under DIS, several plant-based proteins score higher than eggs, indicating that the body can extract more usable amino acids from them per gram consumed. A prime example of this is soy protein. Long stigmatized due to misconceptions about hormones, soy actually provides one of the most complete amino acid profiles of any plant food, including high amounts of leucine, isoleucine, and valine, the 3-branched chain amino acids most directly involved in muscle protein synthesis. In controlled trials, soy protein supplementation has been shown to support muscle growth and maintenance as effectively as whey protein in both younger and older populations when consumed in sufficient doses. Beyond soy, proteins from legumes like lentils, chickpeas, and peas have demonstrated significant anabolic potential, especially when prepared in ways that reduce anti-nutritional factors and enhance digestibility. Another overlooked option is quinoa, a grain that contains all 9 essential amino acids in substantial amounts. Quinoa ranks higher than eggs in certain DIS comparisons because it provides a dense package of amino acids with excellent digestibility once cooked. Similarly, combinations of plant proteins, such as rice and beans, or peas and corn, create complementary amino acid profiles that are not only complete but also surpass eggs in terms of net muscle building capacity. What this shows that the notion of plant proteins being incomplete is largely a myth when viewed through the lens of practical dietary patterns rather than isolated food items. The superiority of some plant proteins over eggs becomes even more apparent when considering aging populations. As people enter their 60s, 70s, and beyond, they begin to experience anabolic resistance, a decline in the sensitivity of muscle tissue to amino acids. To counteract this, older adults require higher doses of protein or more leucine, rich sources to trigger muscle protein synthesis effectively. While eggs contain all essential amino acids, their leucine content is relatively modest, meaning an older adult would need to eat a large number of eggs in a single meal to overcome anabolic resistance. In contrast, certain plant-based proteins like soy isolate or pea protein concentrate deliver leucine more efficiently in concentrated servings, allowing older adults to reach the anabolic threshold with fewer calories and less digestive strain. It's also worth noting the role of anti-inflammatory and antioxidant compounds present in many plant-based proteins. Muscle growth and repair are not only about amino acids, they also depend on the body's ability to regulate inflammation and oxidative stress. Chronic low-grade inflammation, which tends to rise with age, can blunt muscle protein synthesis and accelerate sarcopenia, the age-related loss of muscle mass. Many plant proteins naturally come packaged with phytonutrients, flavonoids, and fibers that reduce inflammation and support gut health, indirectly enhancing the muscle-preserving effects of the protein itself. Eggs, while nutritious, do not provide these additional protective compounds in the same way, making plant-based options uniquely advantageous in an older demographic. Economic accessibility is another factor that elevates the value of plant proteins. Eggs are relatively inexpensive in many parts of the world, but foods like lentils, beans, and chickpeas often cost even less while offering more total protein per dollar and fewer associated health risks like elevated cholesterol in sensitive individuals. For communities and individuals who face financial or geographic limitations, the ability to maintain muscle strength into old age using simple, widely available plant foods is transformative. It shifts the narrative from muscle health being a privilege of those who can afford supplements and animal protein to being accessible to nearly everyone with basic staples. The way plant proteins interact with other lifestyle factors also reveals their potential to outperform eggs. For instance, research shows that when plant proteins are consumed in combination with resistance training, the increases in muscle mass and strength are nearly indistinguishable from those seen with animal proteins. This suggests that the body's anabolic machinery is more concerned with the availability of essential amino acids than with the original source. In fact, older adults who consumed higher proportions of their protein from plant sources while still meeting total daily protein requirements displayed equal or better preservation of lean muscle mass compared to those relying heavily on animal proteins. Preparation and timing are critical in unlocking the muscle-preserving benefits of plant proteins. Soaking, sprouting, fermenting, or cooking legumes and grains not only improves their digestibility, but also increases the bioavailability of key amino acids. Fermented soy foods like tempeh or miso, for example, provide a highly digestible form of protein alongside beneficial probiotics that improve gut health and nutrient absorption. When these foods are incorporated into meals strategically spaced across the day, they can provide a steady stream of amino acids that keeps muscle protein synthesis active, something that becomes particularly important in older adults whose bodies may not respond as strongly to infrequent large protein doses. The psychological factor cannot be ignored either. Many older individuals struggle with appetite, chewing, or digestive issues that make large servings of dense animal protein unappealing. Plant proteins, which can be prepared in soups, stews, or shakes, often offer a lighter, more palatable alternative that ensures consistent intake. For someone in their 70s or 80s, being able to comfortably eat lentil soup or a pea protein smoothie might mean the difference between hitting their anabolic threshold daily or falling short and losing muscle mass over time. What truly shifts the conversation, however, is the growing body of evidence showing that diets emphasizing plant proteins correlate with not just better muscle preservation, but also improved overall health markers. Reduced risk of cardiovascular disease, better blood sugar regulation, and lower systemic inflammation all contribute to an environment in which muscles can thrive. The integration of muscle-specific benefits with broad systemic advantages makes plant proteins an even stronger contender when compared to eggs, which, while beneficial in some respects, do not offer the same broad-spectrum protective effects. As these findings continue to emerge, it becomes clear that the old hierarchy of protein sources needs reevaluation. Eggs, long held as the benchmark of protein quality, are no longer the undisputed champion in the context of muscle preservation, especially at advanced ages. Instead, Affordable, widely available plant proteins are stepping into the spotlight as not just adequate, but in many cases superior tools for maintaining strength, vitality, and independence well into later life. Nutrition, resistance training, and sleep represent the three central pillars of building and preserving muscle across the lifespan. Each one on its own contributes to muscle health, but it is their combination and synergy that maximizes results even in older adults. The interplay between what we eat, how we train, and the quality of our rest determines not only how much muscle we can build, but also how long we can sustain it into advanced age. Understanding this triad requires looking closely at how each factor influences the biology of muscle and why they cannot be separated if the goal is lasting strength, function, and resilience. Nutrition forms the foundation because without the right building blocks, the body simply cannot synthesize new muscle tissue. Proteins provide the essential amino acids required to stimulate muscle protein synthesis, with leucine acting as the key trigger for the mTOR pathway. Carbohydrates support glycogen replenishment, fueling repeated bouts of resistance training, while fats regulate hormones such as testosterone and growth hormone that directly impact muscle metabolism. The balance of these macronutrients, combined with micronutrients like vitamin D, magnesium, and zinc, ensures the internal environment is primed for muscle growth and repair. Timing also plays a role. Consuming sufficient protein in multiple meals throughout the day appears to be more effective than concentrating protein in a single meal, especially for older adults who face anabolic resistance. Each evenly spaced protein-rich meal represents another opportunity to stimulate muscle protein synthesis, stacking these signals over the course of the day. Resistance training, however, is the actual stimulus that gives those nutrients direction. Muscles adapt to the stress placed upon them, and without sufficient stress, the signal for growth is muted no matter how much protein is consumed. Mechanical tension, metabolic stress, and muscle damage are the three main drivers of hypertrophy, and resistance training provides all three in a controlled and progressive manner. Lifting weights, using resistance bands, or even performing bodyweight exercises forces the muscle fibers to recruit more motor units and to adapt by becoming larger and stronger. For older adults, resistance training is especially important because it combats sarcopenia and improves neuromuscular function, coordination, and balance. Even modest programs, such as training 2 to 3 times per week with progressive overload, have been shown to produce significant increases in muscle mass and strength in people well into their 80s. Without this stimulus, even the best nutrition cannot fully prevent the decline of muscle tissue with age. The synergy between nutrition and resistance training lies in how training increases the muscle sensitivity to amino acids. After a resistance training session, the muscle enters a heightened anabolic state that lasts for several hours. During this window, protein consumed is directed more efficiently toward muscle repair and growth. This is why combining adequate protein intake with regular training produces results far superior to either strategy alone. An older adult who only eats high-quality protein but does not train will still lose muscle mass over time, while someone who trains hard but consistently fails to meet protein needs will also fall short of their potential. Together, the two strategies multiply their effects, creating an environment where the muscle is both stimulated to grow and supplied with the materials to do so. Sleep is often overlooked, but it plays an equally critical role. During deep stages of slow wave sleep, the body releases growth hormone, one of the most powerful anabolic hormones. This surge in growth hormone accelerates muscle repair, tissue regeneration, and fat metabolism. Sleep is also when the body consolidates motor learning from resistance training sessions, embedding new movement patterns, and strengthening neural pathways that improve coordination and strength. Chronic sleep deprivation, on the other hand, raises cortisol levels, reduces testosterone, blunts growth hormone secretion, and interferes with glucose metabolism, all of which directly undermine muscle growth and recovery. Research consistently shows that individuals who sleep less than 6 hours per night have reduced muscle mass, lower strength, and greater difficulty losing fat compared to those who consistently get 7 to 9 hours of quality sleep. The interaction between sleep and nutrition is another critical point. Sleep-deprived individuals not only recover more slowly, but also experience altered hunger and satiety hormones, specifically ghrelin and leptin, which push them toward poor food choices. This can lead to inadequate protein intake, excessive refined carbohydrate consumption, and inflammation, further compounding the decline in muscle health. Conversely, adequate protein intake before bed, such as a slow digesting source like casein or a plant-based protein blend, has been shown to increase overnight muscle protein synthesis, effectively extending the anabolic window into the sleeping hours. This creates a 24-hour cycle of stimulus and repair that optimizes results. Resistance training also interacts with sleep in ways that magnify benefits. Exercise increases the drive for deep sleep by raising adenosine levels, the neurotransmitter that builds up with activity and promotes sleep pressure. People who engage in regular strength training often fall asleep faster, experience more restorative slow-wave sleep, and wake feeling more recovered. This creates a reinforcing loop. Training improves sleep quality, which enhances recovery and growth, which then allows for better training performance. For older adults who often struggle with fragmented or shallow sleep, resistance training can be one of the most powerful interventions to restore sleep quality and, by extension, preserve muscle health. The combination of all three, nutrition, resistance training, and sleep, also has profound effects on hormone balance. Testosterone growth hormone and insulin like growth factor 1, IGF-1, are all elevated when proper training, diet, and sleep are in place. These hormones are critical for muscle hypertrophy, bone density, and fat metabolism. Cortisol, the catabolic hormone that breaks down muscle tissue, is naturally kept in check with adequate rest and recovery. Even at age 70 or 80, the hormonal environment can be shifted toward a more anabolic state through consistent application of this triad, effectively slowing or reversing aspects of the aging process at the muscular level. What makes this especially powerful is that the system is adaptable to individual capacity. Someone does not need to train like a bodybuilder or consume massive amounts of protein to see benefits. For an older adult, simply performing squats using a chair, lifting light dumbbells, or using resistance bands while consuming 25-30 grams of protein per meal and committing to consistent sleep hygiene can transform their physical function. The same principles scale upward for athletes and younger individuals who can handle more intense training loads and greater nutritional demands. The biology is the same, only the volume and intensity shift. Another dimension worth considering is recovery beyond sleep, including practices like non-sleep deep rest, mindfulness, and stress reduction techniques. These practices reduce baseline cortisol and improve the autonomic nervous system's balance between sympathetic fight or flight and parasympathetics and rest and digest states. This balance influences digestion, nutrient absorption, and the body's readiness to engage in training. By managing stress through restorative practices, individuals enhance both the effectiveness of their workouts and the utilization of the nutrients they consume. Ultimately, the concept of maximizing muscle health is not about choosing one strategy in isolation, but about layering them together. Nutrition supplies the raw materials, resistance training provides the blueprint for adaptation, and sleep orchestrates the repair and rebuilding process. Each one amplifies the others, and when combined consistently, the effects are not merely additive, but exponential. This integrated approach explains why people who pay attention to all three pillars experience not just larger muscles, but also greater strength, endurance, resilience, and overall health, regardless of age.